Assalamu alaikum, student. Today we are going to discuss about the physical state of matter. It is the fifth chapter of ninth chemistry. Actually, we are going to discuss about the revision class of ninth chemistry, chapter number 5, physical state of matter. Okay, let's start now. Firstly, introduction. Firstly, we check the introduction of this chapter. Firstly, we discuss about the matter. What is matter? As you know, that matter is anything that has mass and occupied space is called the matter. In this chapter, we classified the matter into three categories. Like firstly gas, and second one is the liquid, and third one is the solid. And the next, for the gas introduction, gas is the simplest state of matter, and we can analyze as do not have definite shape and volume. Okay, we do not gases do not have definite shape and volume. And the second one is the liquid state. In this liquid state is the less common in the nature. You can find only type of mostly in the type of water, like in ocean, rivers, lakes, and etc. So this is the less common, and it has property do not have definite shape and but have definite volume. Okay, next one is the solid state. It is the most common, and you can guess as in your around like books, bags, laptops, chairs, tables, wall. These are the solid. So solid are the most common, have and its properties have definite shape and volume. Okay, next one is the let's now first of these state of matter is the gas. Now we are going to discuss about the typical properties of gas. It is a more detail on the gas. First is the property is the diffusion. Diffusion is first one is the diffusion, and fusion, pressure, compressibility and mobility, and the other one is the density. These are the 6 factors majorly. And firstly we are going to discuss about the diffusion. Firstly, definition: spontaneous intermixing of the molecules by random motion to form homogeneous mixture. So there is the spontaneously intermixing of molecules by random motion to form homogeneous mixture. Which mean जो खुद ब खुद चीज़ों का इंटरमिक्स होना, ठीक है, उनका बाय रैंडम मोशन के साथ बेतरतीब अंदाज की हरकत के साथ बेतरतीब मूवमेंट की वजह से उनका मिक्सअप हो जाना और उसका होमोजीनियस मिक्सचर बनना, उसको हम डिफ्यूजन काउंट करते हैं. होमोजीनियस मीन वहाँ पे एक ही सिंगल फेज नजर आ रहा होता है, ठीक है. And the next one is the diffusion depend upon molecular mass. If the molecular mass is the greater, the diffusion will be less. It means lighter gases can more diffuse as compared to heavier one. इसका मतलब ये हुआ कि जिनका मास कम होता है वो जल्दी डिफ्यूज कर सकती है गैसेस, और जिनका मास हैवी होता है वो लेस डिफ्यूज करती है. Like we have an example. In this example, you can see that is the hydrogen gas. It can be diffused 4 times greater as compared to the oxygen one. Hydrogen has 2.00016 gram mass, while the oxygen contains 32.0 gram. So hydrogen has less mass as compared to the oxygen one. So hydrogen can diffuse 4 times greater as compared to the oxygen. And the next one is the fusion. You can see that here these are the important MCQs like this, and homogeneous mixture for diffusion necessity. Okay, next one is the fusion. Fusion is the escaping of gas molecule through a tiny hole. टाइनी होल के जरिए जो है वो छोटे सुराख के जरिए गैस के मॉलिक्यूल का escape आउट होना, निकल जाना, अपनी सरफेस के छोड़ के जाना, ठीक है, from higher pressure to lower pressure, ठीक है. Like जो है example, we have an example like tire puncture. In this the phenomenon tire contains the have heavy pressure in this in the inner side of the tubes, while out in the surrounding in the environment has lower pressure of gases. So when the tire get puncture, gas release into the atmosphere. तो ये वाला एग्जांपल है कि लाइक टायर पंक्चर जो होता है उसमें ये फेनोमेना होता है कि जो टायर के अंदर ट्यूब होती है उसमें हाई प्रेशर काउंट होता है, क्योंकि उसके ऊपर मास भी लग रहा होता है, लाइक व्हीकल का, गाड़ी जो भी है हमारे पास. तो इस तरीके से जब उसमें टाइनी होल होता है तो उसके जरिए जो गैस है वो स्केप हो जाती है, बाहर निकल जाती है. कहाँ पे? लोअर प्रेशर वाली साइड पे, हाई प्रेशर से. So this is the example. And the next one is the fusion depends upon molecular mass. A fusion depends upon molecular mass. It is also depend upon molecular mass. The first one is the diffusion and the second one fusion. Both are the depends upon molecular mass. If greater the molecular mass, will be the fusion will be slowly. Like here we have lighter gases are more diffused as compared to heavier one. मतलब जिनका मास कम होगा वो जल्दी डिफ्यूज कर जाएंगी, एफ्यूज कर जाएगी, और जिनका मास ज़्यादा होगा वो थोड़ा टाइम देंगी. And the next one is the important typical properties is the pressure. Pressure force exerted per unit area is called the pressure. Pressure is can be counted as force over area. Force and over area. This is the pressure, and we can find the unit force having the unit Newton and the area has the meter square. So we can calculate Newton per meter square is the unit of pressure. It is important for MCQs. And the next one is the 1 Newton meter square per square is equal to 1 Pascal, because the pressure concept discovered by the Pascal scientist, so it is contained as the name of scientist here, like a unit Newton per meter square is equal to 1 Pascal. And the next one is the measurement instrument using to measure the pressure of gases, like barometer. Barometer, it is an instrument used for to measure the atmospheric pressure. तो जो बैरोमीटर होता है इसके जरिए हम एटमॉस्फेरिक प्रेशर को मेजर कर रहे हैं. द सेकंड वन इज द ऑपरेटर्स वी कैन यूज एज मोनोमीटर एज द लेबोरेटरी प्रेशर. We can find the laboratory pressure by using the manometer. So this is the two operators we can use. And the next one is the important definition of standard atmospheric pressure. STP known as, ठीक है, इसको हम STP के नाम से भी जानते हैं. स्टैंडर्ड एटमॉस्फेरिक स्टैंडर्ड टेम्परेचर प्रेशर होता है वो. ये स्टैंडर्ड एटमॉस्फेरिक प्रेशर है. प्रेशर exerted by the mercury column of 760 mmHg at sea level. सी लेवल जो हमारा समुद्र का लेवल होता है उसके ऊपर जो मर्करी का प्रेशर लग रहा होता है 760 मिलीमीटर हाइट तक जाता है, तो उसी को हम काउंट करते हैं एज अ स्टैंडर्ड एटमॉस्फेरिक प्रेशर, एयर प्रेशर ऑन द सी लेवल. So we can find with the help of a thermometer, like use 1 atm is equal to 760 mmHg. And we can next one is the comparison of one atmospheric pressure. It is equal to 760 torr, and the next one is the 10 13 25 Newton per meter square or Pascal. So this is the comparison. I like examiner can be asked from you 1 atm is equal to that of the Newton per meter square in the values like 760, 730 and the 10 13 25. So you can tick on the 10 13 25. And the other one is also 1 mmHg is equal to 1 torr. This is an important MCQs. And the next one is the compressibility. This is important. Gases are highly compressible due to empty spaces between their molecules. So we can compress easily because gases contain more space as compared to they have a weak intermolecular forces or no intermolecular force. So gases molecules move randomly and contain spaces between their molecules, and we can compress. In this phenomena, by compressing the air particles or gas particles, they come too close to each other, so they occupy the less volume when we apply the pressure or using compressibility factors, like occupied less volume on compressing, yes, by applying the pressure. This is already discussed. We have occupied the less volume. If we apply pressure, then we using the process of compressibility. When we compress the air or gases, they come too close to each other, so they occupy less volume. And the next one is the mobility factor. Gases molecular has possess high kinetic energy. गैसेस मॉलिक्यूल्स के पास जो है वो हाई काइनेटिक एनर्जी होती है, ठीक है. मॉलिक्यूल्स तभी जो है वो फ्री रैंडमली मूव कर रहे होते हैं, सो दे कैन मूव फ्रीली. इसी वजह से वो मूव फ्रीली कर सकते हैं वन प्लेस टू अनदर प्लेस. सो इट्स मींस गैसेस आर मोबाइल. इट मीन गैसेस आर मोबाइल. मोबाइल मीन फ्री होता है. they always keep in continuous motion. So when these are having high kinetic energy, so they keep remain in the continuous motion. Okay, these are the factors. And the next one is the last one is the factor density. Okay, come to on topic density. Gases and liquid and solid. You can see that gases have lower density as compared to liquid, and liquid has lower density as compared to solid. Because gases has no intermolecular forces, liquid has much as compared to gases much intermolecular forces, but solid has strong intermolecular forces. So solid has high density, liquid and less, and gases have low density, lowest density, due to light mass and more occupied volume. So gases have less density. गैसेस का जो मास होता है वो कम होता है और वॉल्यूम जो है वो ज़्यादा ऑक्यूपाई करती है, सो दे आर कंटेन एज द लेस डेंसिटी. नेक्स्ट वन इज द फैक्टर गैसेस डेंसिटी मेजर्ड इन जीडीएम क्यूब. जीडीएम क्यूब जो है वो एक हैवीएस्ट यूनिट है उसको मेजर करने के लिए, क्योंकि यहाँ पे हमारे पास जो गैसेस मॉलिक्यूल्स होते हैं वो बहुत ही छोटे होते हैं, ठीक है. उनकी मेजर करने के लिए हम एक जो है वो डेसीमीटर क्यूब का फैक्टर यूज करते हैं मेजरिंग करने के लिए. जैसे डेसी पढ़ा है ना आपने, डेका हेक्टोकिलो मेगा गगा टेराबिटा हेक्सा, तो वो वाला जो प्रीफिक्सेस वाला सिस्टम है, ठीक है, उसमें ही डेसी आता है, डेसी के बाद सेंटी आता है. तो डेसी जो है एक मोर ऑक्युपाई कर लेती है स्पेस. तो इस तरीके से वहाँ पे गैस मॉलिक्यूल्स जो बहुत कम होते हैं तो उनको कैरी करने के लिए हम जो है जीडीएम क्यूब यूज करते हैं. इट इज इंपॉर्टेंट एमसीक्यूज. एंड द नेक्स्ट वन इज द लिक्विड एंड सॉलिड डेंसिटी मेजर्ड इन द जीसीएम क्यूब. द सेम एज liquid gases liquid and solid has stronger intermolecular forces, so they contain less space we use to find the density in GCM cube. And the next one is the comparability comparison. 1000 cross liquid and solid greater as compared to gases. It's mean the gases has lowest density 1000 times as compared to liquid and solid. Or we can say that 1000 times density of liquid and solid are greater as compared to the gases. And the gases density increases on cooling. When we cool the gases, its density increases because volume they contain less volume. When we cool the gases molecules do not move freely, so they occupy less volume and contains more number of the molecules at one place, so it has gases density increases. And for example, we have oxygen 1.4 GDM cube at 20 degree. It is the more temperature as compared to the second one is the 0 degree. So oxygen has 1.5 GDM cube at 0 degree. So you can see that here 20 degree is at a larger temperature as compared to 0 degree. So at large temperature have low density, at low temperature has high density, because at low temperature we gain the cooling process. Okay, next one is the laws related to gases. Laws related to gases, like there are two laws. Is the first of one of the Boyle's law, second one is the Chaucer's law. First we are going to discuss about the Boyle's law in detail. In 1662 Robert Boyle discovered this phenomena, in which we can see that the volume contained by a gas is inversely proportional to its pressure. If we apply the pressure, the volume will be decreased. It means it is the inversely relation. If we increase the first one, the second one will be decreased. If the first one decrease, will be the second one increase. It is the inverse relation. So volume is denoted by V, and the 1 over P is equal to 1 over pressure. It is important factor. At this in the Boyle's law we keep the constant factors like temperature and mole. This is important for MCQs. What one is the factor constant remains in the Boyle's law? So temperature and number of moles, like quantity of substance, quantity of molecules remains constant. We do not change. Okay, this is the Boyle's law. Let me see the explanation in details for long question. Okay, here you can see that the explanation, like Boyle's law in 1662 Robert Boyle studied relationship between volume and the pressure of the gas at constant temperature. This is the definition of Boyle's law, and in this it is the actually definition is the volume of the given mass of gas is inversely proportional to the pressure provided by the provided the temperature remains constant. So in this phenomena, we in the Boyle's law we keep the constant is the temperature. According to Boyle's law, volume V and pressure P, we can see that volume is inversely proportional to 1 over P pressure V is equal to 1 over P. So if there is we using the to release the proportionality sign, we can use a constant K is equal to Vp, and we can write as K is equal to Vp, and K is the constant. Here is the more explanation. K is the constant. If we use any type of gas, it will be keep constant. Like we can see that here. Okay, you can see that here. If we P1 and V1, it is the first pressure and volume of the gas, given gas, and this is the P2 and V2 of the given gas. Like if we change the firstly when we take in the initially, so then will be the initial pressure and initial volume will be contained, and at the end of when we change the pressure or volume, then we contains at the end of the final volume and the final pressure and the final volume. So we can write as K keep constant K, so we can write as P1 V1 is equal to P2 V2. And the next one is the experimental verification of Boyle's law. Relationship between volume and pressure can be verified experimentally, so you can see in detail in your book. Okay, next one is the Charles law. It is published in the 1787 by John Charles. Volume is directly proportional to the temperature. If we increase the temperature, the volume will be increased. Because when we increase the temperature, the kinetic energy of molecules increases, which exert the pressure on the movable piston, so the volume increases. V is directly proportional to the T. And in this phenomenon, we keep constant pressure and the moles. It means number of particles, number of molecules, atoms of a given substance, they keep constant and pressure constant. Okay, V directly proportional to T. Let me see in the detail. Okay, here you can see that J. Charles in 1787 presented the law of state volume of the given mass gas directly proportional to its temperature, and the pressure is kept constant. So you can here see that in your book in the detailed topic. It is the long question. Let me see an example and next topic. Okay, next one is the absolute temperature scale. Here discovered by Lord Kelvin. It was discovered by Lord Kelvin. Definition: this is the scale start from 0 Kelvin to minus 0 Kelvin or minus 273.15 degrees Celsius. And the next one we can write as temperature at which ideal gas has become zero volume. Which means ideal gas contains the zero volume. This is the temperature value, and its temperature value is 0 Kelvin. Okay, its range हमारे पास है minus 273 degree Celsius to 273 degree in the plus. ठीक है. Okay, 0 Kelvin to R 0 degree. 0 Kelvin to 0 degree or minus 273 degree Celsius to 273 degree Celsius. Okay, conversion of formulas. This is important for MCQ or short question. If we have given of the temperature in degree, we can convert into Kelvin by using this formula. If we have temperature in like 37, it is our body temperature. We put here 37 and we add it 273. It is to 300 Kelvin. It means our normal body temperature is 300 Kelvin. Next one is the we can convert if we have the temperature in Kelvin into the degree. Like we have the temperature of Kelvin in our body 300 degree. If we put there 300 degree and 300 Kelvin, then we subtract 273, we gain 37 27 sorry 310 आ रहा था. ठीक है, ऐड करने से 37 will be our temperature in degree Celsius. Okay, next one is the interesting information. Here you can see many of the short question come from this interesting information. Firstly, blood pressure measure by pressure gauge के जरिए जो है हम लोग प्रेशर गॉज ऑपरेटर्स है जिसके जरिए हम लोग जब ब्लड प्रेशर मेजर करते हैं. नेक्स्ट जो है वो इम्पोर्टेंट एमसीक्यू है. नॉर्मल बीपी जो होता है ब्लड प्रेशर रेंज जो है वो 120 to 80 होता है. 120 हाई होता है और 80 जो है वो लोअर होता है. मैक्सिमम प्रेशर जो मेजर करते हैं उसका इट्स गिवन नेम्स टू एज सिस्टोलिक प्रेशर. मैक्सिमम प्रेशर विच मेजर बाय ह्यूमन बॉडी ऑफ is systolic pressure. If we contain the blood pressure at the lower pressure value, it is also called the second BP value, which mean second BP mean lower blood pressure value. This is called the diastolic pressure. And BP measured in torr, which mean we measure the blood pressure in the form of torr in the unit of pressure. Here हाई बीपी ड्यू टू हाई बीपी जो है वो हमारा क्यों हो रहा होता है. हाई बीपी ड्यू टू टेंशन मरीज, इट इज कॉल्ड द हाइपरटेंशन. ये जो हम टेंशन ले रहे होते हैं मरीज होते हैं तो वहाँ पे हमारा ब्लड प्रेशर जो है उसकी मूवमेंट इंक्रीज हो जाती है, उसको हम कहते हैं हाइपरटेंशन. The next one is the hypertension cause stress on heart and blood vessels. If we take tension or worries, it's cause of hypertension. Hypertension cause of stress on heart and blood vessels. They can cause of heart attacks and the strokes. So these are the effect of hypertension. Okay, let's see next. Okay, next one is the typical properties of gases. I think student it's very lengthy. We discuss in the next topic, next half chapter revision. Okay. Almost the topic of gases covered. If you have any question you can comment me and I will answer you in a short time. So thank you for watching and subscribe the channel please. Thank you so much.